Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are checking your answers. You have homework about momentum paper 2 for extended candidates only. Before we start, go and check notes playlist. You will find notes about momentum, which is very important, and you can check classwork part 1 and part 2. Okay, let's start by question number 1. Question number 1 is very simple. It's asking you about momentum. What is the correct equation we are using to calculate momentum, and if you know momentum, is it a vector or a scalar quantity? For sure you know that momentum is a vector quantity, and you can calculate momentum by multiplying mass and velocity of the object. But here, so the correct answer is B. Product of mass and velocity, and it's a vector quantity. But here I would like to focus on the concept of momentum itself. It's a measurement of mass in motion. If the object is at rest, so it has no momentum. Okay? Let me know in the comments, what do you know about the expression momentum in our daily life? Sometimes we are using this expression, okay? Keep the momentum. Question 2 is very simple. Which expression gives the momentum of an object? You know that the equation used to calculate the momentum, mass times velocity, so your correct answer is C. But let me check the other choices. Mass times acceleration, this is the resultant force. Mass times gravitational field strength, which is G. So it's the weight of the object, mass times G. Half mv squared, which is the kinetic energy, half mv squared. Question 3. A stone of mass 0.12 kilogram is fired from a catapult. The velocity of the stone changes from 0 to 5 meters per second. The time taken for this change is 0.60 seconds. First of all, check you have consistent units. Okay, what is a catapult? It's like a stick. It has an elastic band sometimes used by children for shooting small stones. Okay, what is the average resultant force acting on this stone while it's being fired? Okay, the average force according to Newton's second law of motion is equal to the rate of change of momentum. So it's m delta v divided by delta t. What is delta v? It means final velocity minus initial velocity divided by time taken for this change. When you substitute, you have the mass in kilogram, 0.12 kilograms, and you have final velocity, which is 5, minus initial velocity, which is 0, divided by time taken here, which is 0.60 seconds. Your final answer will be 0.99, which is 1 Newton. So your correct answer here is A. Question 4. Question 4 is challenging and is very important. Okay, a moving ball, it has a momentum. You have here the value, the magnitude of the momentum already, which is 25 kilogram meter per second. Collides head on with a wall and it rebounds. When you see here expression rebounds, recoils, you have to pay attention and you have to take into consideration directions. Okay, it rebounds from the wall. It has here the same speed when it recoils. Okay, so when this ball collides with the wall, it recoils, but the direction changes in opposite direction. The time of collision is 50 milliseconds. So number one, why it's a challenging question, you have here to convert units to make sure you have consistent units. So first of all, 50 millisecond to second, you have to multiply by 10 to the power of -3 using your mathematical skills, scientific notation and standard form. So you have to change millisecond to second. Your answer will be 0.05 seconds. Okay, what is the average force exerted on the wall by this object, by this ball during collision? So again, we have Newton's second law of motion representing here the average force is equal to rate of change of momentum, which is m delta v divided by delta t. When you substitute here, you have the time for this collision after conversion, it's 0.05 seconds. And here the change in momentum, you don't have mass and you don't have velocity, you have the momentum before collision, and you should, since momentum it's a vector quantity, as I told you, you should take into consideration here the direction of velocity, so the direction of momentum. It has same speed, so same magnitude. Momentum after collision also will be 25, but it has a negative sign. It has a negative sign. So here we have -25, which is the momentum after collision, and you will subtract here momentum before collision, which is 25. Okay, so before collision you have momentum 25 kilogram meter per second, but after collision here you have -25 kilogram meter per second. When you subtract here the change in momentum, your answer will be -50 divided by 0.05. Your answer will be 1000 Newton. The correct answer here is D. Question 5, we have a car, it has a mass 1000 kilogram traveling at a speed 8 meter per second, collides with a lorry of mass 3000 kilogram, and it will move or travel at 2 meter per second in the same direction. After collision, the two vehicles stick together as one object. In all cases, I am using, or I will apply here, the principle of conservation of momentum, and it's common in all cases. If they stick together, I will rewrite it in another form as common mass or combined mass and common velocity. Okay, so let's write down the principle of conservation of momentum. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here we have the case of after collision they stick together as one object, so you have m1 plus m2 combined mass and they will have the same velocity. Let's substitute to get their speed after collision. So when you substitute here the mass of the first car times its velocity, its initial velocity, which is 8, plus the mass of the lorry, which is 3000, times its initial velocity, which is 2, is equal to the common mass, which is 1000 plus 3000, and you have the common or the velocity of car and lorry when they stick together. When you substitute, you can get your answer. It's clear and simple. Your correct answer is 3.5 meter per second. Your correct answer is C. Question 6, here we have a bullet of mass 0.10 kilogram travels horizontally at a speed of 600 meter per second. Okay, it strikes a stationary wooden block. After collision, or after it strikes the block, it sticks, or it will stay in the block like this. Okay, in this case, what is the speed of the bullet and the block immediately after the impact, after this impact? Also, we have to apply the principle of conservation of momentum. m1 u1 plus m2 u2 plus m2 u2 is equal to m1 v1 plus m2 v2. But in this case, we have combined mass because after impact, they will act as one object. They have combined mass and they have common velocity. So when you substitute, let's substitute the wooden block, it was stationary. So all this term, its momentum before impact is 0. The momentum of bullet before collision, its mass 0.10, check you have consistent unit, times 600. Common mass, you have here 0.10 plus the mass of the wooden block, which is 1.9. The common velocity, you are trying to calculate their velocity after impact. Substitute, your answer here is 60 is equal to 2 times v. So your correct answer, v is equal to 30 meter per second. Is it clear? Your correct answer is A. Question 7 is repeated. Kindly check classwork part 1 and part 2. Let's move to question 8. Question 8 is challenging and is very important. We have here an object is moving at a speed 3 meter per second, and there is a force acting on this object. After a certain time, the object is moving at a speed negative, or at a velocity 4 meter per second. The mass of the object is given. What is the change in momentum? Okay, so we have here an object, okay, 5 kilogram, is moving in a certain direction. It has a velocity, v initial is 3 meter per second. Okay, when a force is exerted on this object, there is a force here exerted on this object, what happens here to the velocity? Its velocity becomes negative 4 meter per second. Okay, so in this case you have to apply the equation change in momentum. Can be calculated using impulse is equal to change in momentum. So we have here m delta v you have to substitute here v final minus v initial. The mass is 5. Check you have consistent units. V final, so you have to substitute V final, -4, but here you have subtraction, okay, and you have V initial, which is 3. Okay, so the final answer is 5 times -7, which is -35 kilogram meter per second or Newton second. Is it clear? Question 9, we have here two objects, an object P and object Q. The first sentence here after collision, so pay attention because some students, they consider the first sentence before collision and the second sentence after collision, so pay attention. The second point why this question is challenging, you have to check you have consistent units. Masses here are given in grams, not kilograms, so you have to convert units. So the first mass of object P, object P is equal to 80 grams. So you have to convert it to kilograms. You have to multiply by 10 to the power of -3. Your answer is 0.08 kilograms. Mass of object Q is also 40 grams. So the answer is 0.04 kilograms. Okay? When you apply the principle of conservation of momentum, so we have here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. What happens after collision? They stick together and travel on together. So we have here combined mass, and we have here velocity. They became one object, so they have the same velocity. When you substitute here the mass of the first object P, you have to substitute 0.08 times its velocity before collision, which is 6 meters per second, plus Q before collision, it was at rest, so its momentum before collision, it was 0. So the common mass is 0.08 plus 0.04, and we are looking for common velocity. When you substitute, you have your answers here. 0.48 is equal to 0.12 V. So the answer is V is equal to 4 meters per second. Your correct answer is C. The last question we have today in our homework, question 10, we have a ball of mass 0.50 kilogram falls, so this is before collision, it falls and hits the floor at 10 meters per second. It rebounds at speed 8 meters per second. So here, again guys, you have to take into consideration directions. The collision between the ball and the floor, it takes 0.50 seconds. Check you have consistent units. What is the average force acting on the ball during collision? Okay, here you have to apply the law, Newton's second law of motion. So you have force is equal to m delta v divided by delta t, which is mass. You have here v final minus v initial divided by time taken. When you substitute, you have to remember velocity, it's a vector quantity. So you have the mass here, you have here subtraction, you have here the time, which is 0.50. When you substitute, you have final velocity, its magnitude is 8, but you have to write it here -8 because it's in opposite direction to the direction before collision when the ball was falling. And here the initial velocity is 10. Okay? When you get your answer will be -9 divided by 0.50. So your answer is -18 Newton. So you have to choose between, you have to exclude A and B. You have to choose between C and D. How can you know the correct answer? According to the sign here. If you have negative sign, okay, the negative sign here, when you substitute it represents upwards. It represents upwards. So this negative sign means in opposite direction. In opposite direction to the initial case. Opposite direction. In the initial case, it was before collision downwards. So here we have to choose C. Magnitude is 18 Newton. According to the answer, we have here negative in opposite direction to the original case. So the original case it was downwards. So you have to choose your answer.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor.